In this screencast, we'll see how to use Statkey to create bootstrap confidence intervals based on randomization. So let's look at a couple examples. Suppose we want a confidence interval for a single mean. Well, here we are in Statkey. We'll go to bootstrap confidence intervals for a single mean. And we'll just look at one example, commuting time in Atlanta. So this is one of the ones that's pre-programmed, data from our textbook. And in the original sample, it was sample of 500, and the mean was 29.1. So what Statkey does is take as many bootstrap samples as we want and creates a dot plot of them, and from that we can get an estimated 95% confidence interval. So let's just generate 1,000 samples, and each of these 1,000 dots represents one bootstrap sample of size 500. And we can see that the means of those 1,000 bootstrap samples vary, and they vary, but not by a whole lot. And to find a 95% confidence interval, we'll just click on this, to tail, and it tells us that in 1,000 samples, the mean commute time in each of those samples varied between 27.3 and 31.1. So that's our 95% confidence interval. We can be 95% confident, roughly speaking, that the average commute time for all commuters in Atlanta, Georgia, is between 27.3 minutes and 31.13 minutes. And if we had taken a different 1,000 samples, our results would have been a little different, but not much. And if we'd wanted a 99% confidence interval, we would just change this 0.95 to 0.99. And then we see that it's with 99% confident that the actual mean commute time is between 26.8 and 31.7. And for different confidence intervals, so for different parameters, the process is pretty much the same. So how about confidence interval for difference in proportions? So this is data from use of text messaging, and amongst 800 teenagers surveyed, 696 used text messages. I'm not sure whether that means used text messages daily or at all or whatever, but whatever they're measuring here, 696 out of 800 for teenagers, and for adults it was 1621 out of 2252. And so for the difference in the proportions of the two groups, well, we'll do bootstrap sampling again, and we'll generate 1,000 samples, and again do to tail, and we see that the difference in the two groups is between about 12% and 18%, or 0.12 rounding to 0.18. So we're 95% confident that the difference in the proportion of teens who use text messaging and the proportion of adults who use text messaging is between 0.12 and 0.18. And if we had taken a different sample of 1,000, we would have gotten slightly different numbers if we go to 3 places, but rounding to the nearest 2 places, it's exactly the same, 0.12 to 0.18. Now, here we're using data that's built in that comes equipped with Statkey. What if we want to enter our own data? So let's look at an example of that to investigate correlation coefficient. Here's data for the age and price of 15 Honda CR-Vs. So we're going to use that with which formula? Correlation for slope and correlation. So this part is Statkey. And we're going to edit the data. And now notice what the data wants. It wants 2 columns. But remember that Statkey likes numbers. It doesn't like dollar signs or commas. So we'll go back to our data here, and we change the format of the price of the cars to general. And now we're ready to select, copy, and paste it over this. We still have headers in the first row, namely age and price, and now we hit OK. So in our original data, sample size 15, we had a correlation coefficient of negative 0.95. And then we get 1,000 bootstrap samples and make it two-tail. And we see that it varies between negative 0.98 and negative 0.907. And again, if we had taken a different 1,000 samples, it would have been a little different, but not much. So we're 95% confident that the actual correlation between the age of a Honda CR-V and its price is negative 0.98 to negative 0.90, or 90 in this case if we round to the nearest 100th. And again, we can change the level of confidence if we want. So that is how it's done.